If a 2 kilogram object rests on a table, what is its weight? What is the force on the same object if it is dropped to the floor? So the first thing we need to do for this problem is to identify any concepts that we're going to be using. So under identify, we have an object. We can go ahead and label any relevant concepts, variables, and the target variables that we're looking for. So we are looking for the weight, and we are also looking for the force. So for this problem, we are given that the mass, which is going to be labeled as m, is given as 2 kilograms. And we also know the acceleration of the object, which is going to be g for gravity. And for this problem, we're going to give it a value of 10 meters per second squared, just to make it easy. And the relevant concept that we're going to be using is Newton's second law. We're going to be using F equals ma. And we're also going to be using that the weight is equal to mg. Now remember, the force we're looking here is going to be the sum, and we're going to pick a direction, ideally y. So let's go ahead and go to our second step, which is going to be the setup. We're going to use the down direction as the positive y direction. So when we're labeling all of our forces and pluses and minuses, we know what direction we're going to be indicating for our problem. We can go ahead and make the two situations. The first one on the left was when the block is sitting on the table. So we'll use these 2 points as our object. For one, we have the force of its weight pulling it down. And for the other one, we have the force of gravity. And for this problem, we had the weight is equal to mg. And for the right hand side, when we are only looking at the force, we have F equals to ma. And since we're going to be neglecting any friction forces due to the air, that's simply going to be mg. And there's nothing slowing down the force pulling it down. So let's go ahead and execute that. So all we have to do is plug in the values that we're given. So for the left hand side, the weight when it's sitting on the table is going to be the 2 kilograms times the 10 meters per second squared. And that's going to be 20 newtons for the weight. Now, for the right hand side, in the second situation, we are looking at the force. And that, again, is going to be mg. So that will equal 20 newtons as well. Now let's go ahead and evaluate this answer to see if it makes sense. Now, we found the weight to be 20 newtons, and we also found the force to be 20 newtons for when it was dropped. Now this makes sense because the weight on the left hand side is 20 newtons, and that is found from the mass times the gravity that's pulling it down. So if it was in a different location, maybe on a different planet that had different gravity, it would have a different force pulling it down. And for the right hand side, when we're looking at the force when it's actually dropped, the only force that's acting on it is actually the weight itself. So this answer checks out.